What exactly is a brushed motor? And what is a brushless motor? One video explains it all. Have you noticed that these days, almost every appliance with a motor will tell you whether it uses a brushed or brushless motor? So what exactly is the difference between the two? To understand that, we first need to know how a motor actually spins. Back in school, we learned that if you wrap wire around an iron core to form multiple coils, when you run electricity through those coils, they become an electromagnet with magnetic poles, just like a permanent magnet. It follows the same rules. Like poles repel, opposite poles attract, and its polarity can be flipped simply by reversing the direction of the current. So if we mount this electromagnet on a shaft and place a permanent magnet on each side, once powered, the electromagnet will spin due to the magnetic forces acting on it. By continuously reversing the current direction to flip the polarity, the electromagnet keeps spinning indefinitely. Now, if we replace the side magnets with stronger curved magnets and simplify the electromagnet down to a single coil, when we power that coil, current flows through it and creates a magnetic field. The coil then experiences a magnetic force and starts to rotate. But here's the problem. When the coil rotates halfway and its poles align opposite to the permanent magnets, it just stops and can't keep going. Just like before, we can reverse the current direction to flip the polarity and keep the coil spinning continuously. But constantly swapping the wires to reverse current direction is obviously not practical. So engineers invented a clever device: the commutator and carbon brushes. The commutator is like a ring split by small gaps, while the carbon brushes press against it using springs to conduct current. You can think of the commutator as an automatic current switcher. Every time the motor reaches a specific angle, it automatically reverses the current direction, which flips the coil's magnetic field. This keeps the force direction consistent, so the coil spins round and round without stopping. To make the rotation smoother, we can add more armature coils and divide the commutator ring into more segments to improve the motor's efficiency. That is what we call a brushed motor. The brushed motor design is a classic, simple and practical, but it has some natural drawbacks. Because the brushes constantly rub against the commutator, they wear out quickly. The contact surfaces can spark and produce electrical arcing, and the motor is noisy, inefficient, and short-lived. That's why the brushless motor was eventually developed. The concept behind a brushless motor is actually pretty easy to grasp. It simply flips the structure of a brushed motor inside out. The stationary part becomes the wound coils, and the spinning part is now the permanent magnet. Since the coils don't move, there's no need for brushes at all. Current switching is handled entirely by an electronic controller, which tracks the rotor's real-time position and precisely delivers power to the right coils to create a rotating magnetic field, which pushes the rotor to spin. Without brushes, there's no friction. So the motor lasts longer, runs more efficiently, and offers much more flexible speed control. However, brushless motors require more complex electronic controllers, sensors, and algorithms to precisely manage current direction in real time, which means higher hardware costs and a much more challenging development and calibration process. That's why appliances with brushless motors typically cost more than those with brushed motors. So now you get it, right?